Good morning, good afternoon, and good evening. What's up, guys? Welcome to my YouTube channel. This is um, this video is about a cloud, CompTI Cloud Plus, uh, maintaining cloud solution part one. And let's start the lab. Okay, welcome to the maintaining cloud solution part one practice lab. In this module, you will be provided with instruction and devices needed to develop your hands-on skills. Learning outcomes. In this module, we'll complete the following exercise. Exercise 1, backing up and restoring configuration file, maintaining the OpenStack environment. After completing this lab, you will be able to back up and restore the OpenStack deploy directory, create partition for the OpenStack instance, create a playboard in an OpenStack instance, create an image for an OpenStack instance, create an internal network for an OpenStack instance, create a security group for an OpenStack instance, create a key pairs for OpenStack instance, create an instance in OpenStack, self reboot an instance, hard reboot an instance, shut off an instance, create a snapshot of an instance. Lab topology during the session will be have access to the following lab configuration, which is the PLAB management, deploy, controller, compute, and storage. Okay, we gonna start for the exercise 1, backing up and restoring configuration file. The slash etc slash openstack underscore deploy slash directory contains details such as the live inventory, host, structure, network information, password, and option apply to the configuration files for each service in the OpenStack deployment. In case of a disruption, you can restore the slash etc slash OpenStack underscore deploy slash directory from its backup. To restore this OpenStack deploy directory, copy the backup of the directory to your cloud environment. In this exercise, will be back up and then restore the OpenStack deploy directory. Okay, devices. We'll be using the following devices in this lab. Okay, let's power on the topology. Task 1. Back up the configuration file. For disaster recovery, it's a good practice to regularly back up the database, configuration files, network information, and OpenStack service details in the environment. For an OpenStack Ansible cloud, you back up the slash etc slash OpenStack underscore deploy slash directory. It's recommended that the backups are made to a remote location. In this task, we'll be back up the etc OpenStack deploy directory. Okay, connect the PLAB management. Okay, we already connected. Then open the PUTTY. Then we choose deploy. Scroll down and open. And we log in as a root. Password. Then to list the contents of the OpenStack deploy directory, type the following. This is a copy. Then enter. After running the command, it lists the files that are needed to back up the configuration bars for the OpenStack instance. Okay, listing the contents of the OpenStack deploy directory. To create backup directory, type this or you can copy it. Okay, check, double check if it is correct or not. Okay, then enter. Creating a backup directory after typing the indicated command. To create a backup of the files, the folder in the EDC OpenStack deploy directory, type the following command. and then enter. Backing up the etc OpenStack underscore deploy directory to the slash bar slash live slash backups slash OpenStack directory. To verify the manual backup was successfully created, type the following command. Okay, let's double check it. We're good to go. Enter. Okay, back up tar. Displaying the backup file was successfully created using the tar command. To list the content of the backup file, type the following command in the terminal. Copy it, then put it here, then enter. Okay. Screenshot of PLA management displaying the contents of the backup file to verify the backup was successfully completed. This one. Okay. Task 2. Restore the OpenStack environment from a backup. Backups are used to restore data if an unforeseen incident has occurred in the environment. The configuration settings for the OpenStack environment are stored in the slash etc slash openstack underscore deploy slash directory. This directory was backup in task 1. In this task, you will restore the OpenStack deploy directory from the backup. Ensure that the terminal session to the PLAB deploy service is still active. This one. Okay, ensuring the connection to the PLD service is active. Verify the location of the backup file by typing the following command in the terminal. Okay, double check ls dash l slash var slash lib slash backup slash openstack and then we enter. Okay, successful. Verifying the location of the backup file. To view the content of the backup file, type the following command in the terminal. Okay, double check again. tar tf var lib backups openstack backup dot tar dot gc say zay. Okay, displaying the content of the backup file. To restore the content of the backup file to the original location, type the following command in the terminal. Okay, double check the password. Okay, we're good to go. Enter. Extracting the backup to its original location. To verify that the backup was a successful, type the following command in the terminal. ad etc openstack deploy and then enter. Displaying the etc openstack deploy directory after the restore was completed. Take screenshot of the PLIB management. Okay, screenshot. And then next. Okay, exercise 2. Maintaining the OpenStack environment. OpenStack maintenance is needed to ensure that the environment runs smoothly and prevent unexpected downtime. Thus, it is necessary to ensure there is a maintenance strategy in place. This strategy can be an automatic or a manual provision strategy. In this exercise, we will implement manual maintenance strategies. Keep in mind that this specific task can be automated in a production environment to ensure consistency of the task performed. Another benefit of automating this specific task is that I will run on a schedule and prevent human error. Learning outcomes after completing this exercise will be able to back up the restore the OpenStack deploy directory, create a partition for the OpenStack, create a flavor in the OpenStack, create an image, create internal network, security group, key pairs for OpenStack instance, create an instance in OpenStack, soft reboot an instance, hard reboot, shut off an instance and create a snapshot of an instance. Okay. Devices we're using is the PLAB management, deploy, controller, compute, and storage. Task 1. Creating partition for the instance on OpenStack. In this task, you will create a partition for an open instance in an OpenStack environment. The partition that will be created will be used to store the data for the instance on the storage server. Storage is a critical resource in cloud infrastructure and needs to be maintained to ensure that the cloud infrastructure function correctly. Okay, step 1, connect the PLAB management. Okay, we're already connected. I'll just minimize this one. For desktop, right click on the PUTI icon and click open. Then select the PLAB storage. Then open. When we log in here as a administrator, not root. And then password. Okay, it shows a successful login after entering the correct username and password. Okay, type the following command to terminal to check the disk. Sudo fdisk-1. Okay, for the administrator password is also a password. Okay, it shows the command has been typed in order to check the disk. The new disk with 160 gig space is present. A new partition needs to be added to the disk. Type the following command to add a partition table in this disk. This is 160 gig. Enter. Okay. And this shows the command has been typed in order to add the partition table in the new disk. For the new partition, type N and enter. It shows the command has been typed for a new partition. For primary partition, type P and then enter. It shows the command has been typed in order to select the partition type as primary. Step 8, for the partition number, press enter. For the first sector, press enter. Similarly, for the last sector, press enter. View the newly created partition by typing P. Okay, the new partition will be dev slash sdb1, this one. To save and quit, type W and then enter. It shows the command has been typed. In order to save the newly created partition, type the following command to confirm the partition added successfully. Then we press enter. Okay. It shows the command has been typed. In order to check the newly created partition, this one. To create the physical volume of the partition, type the following command. Okay, double check the password sudo pbc pb create slash dev slash sdb1. Then we enter. Okay, says volume is successfully created. Check the physical volume has been successfully created by typing the following command. Enter. To create the volume group, type the following command. Okay, double check Cinder volume. Enter. Okay, has been typed. In order to create the volume group, name Cinder volume. In partition, confirm the volume group is successfully created with the following command. Enter. Okay, type the following command to restart the system where changes to take effect. Okay, then we enter this one. Okay, you will see the PUTO fatal error message. Click OK. Okay, right click the PUTTY inactive window and click restart session. In order to restart SSH connection to the PLAB storage. Then log in as administrator. Again, administrator, log in, enter, then password. Click on sign to minimize the terminal. Okay, we minimize the terminal. Creating flavors in an OpenStack instance. In this task, we'll create a flavor in an OpenStack dashboard. A flavor in OpenStack defines the computing memory and storage capacity for the instance virtual server that will be provisioned. Connect the PLAB management. This one. On the taskbar, click the Start button in the bottom left-hand corner. Open the Mozilla web browser. We copy this one. Copy the URL and put it here. Okay. We see the OpenStack dashboard. Not now. You're disturbing my monitor. This will open the OpenStack dashboard. Okay. In username, type admin. Okay, minimize the window by clicking sign. We minimize it. Take the password. PIB show the username has been typed in the open text dashboard. From the desktop, right click on the PUTTY icon, open, and then select deploy. Now it has been selected, followed by a click on open. Log in as a root, password, type the following command to obtain the OpenSec dashboard password, and then enter. Okay, it shows the command has been typed to obtain the OpenSec dashboard. Then press this one and the keystone authorization admin password, and then enter. Displaying how to search for the admin password string. The password for keystone underscore out underscore admin underscore password is displayed at the top of the window on the right of the highlighted keystone underscore out underscore admin underscore password. This one. We highlighted. Oops. Oh, will automatically highlight and edit automatically to be copied to the clipboard. Step 11, open the web browser, click into the password box, and then paste in the copied password. Click connect to open the OpenStack dashboard. Then connect. Okay. After the successful login, the OpenStack dashboard will open. This one. It shows that OpenStack dashboard has been opened after the successful login. On the left side bar of the window, click Admin. This one. Admin. Under Admin, click Compute, which will open further option. Okay, in step 15, under Compute, select flavors. Select flavors. Okay, flavor has been open. The pop-up window show the option to add and parameter for the flavor and the flavor information tab. Flavor defines the size for RAM, display, number of cores, and other resources that can be selected when user deploy instance. This one. In the name text box type, test flavor. Oops. Okay, we create new flavors. Test flavor. Test flavor, and then step 18. Specify the ID for the flavor as auto. This one. Step 19. Now add the number of virtual CPUs required for the flavor. Specify vCPU flavor as 1. Step 20. Enter the amount of RAM, MB, and the megabyte to use for the flavor. Specify the RAM MB for the flavor as 512. In the root disk GB field, enter the amount of the disk space in the gigabytes to use for the root partition. Specify root disk for the flavor. A10. A thermal disk offer machine local disk storage linked to the lifecycle of VM instance. When a VM is terminated, all data on the ephemeral disk is lost. In this case, it would be unspecified and the value is 0 by default. Okay, step 23. A swap disk in Linux is used to increase the virtual memory for a system. When the system runs out of physical memory, the swap disk is used to supplement the memory. Swap disk won't be used during this training. It will be unspecified and the value is 0 by default. RTX TX factor is left unchanged on 1. It shows the flavor parameters with the flavor swap disk in megabits MB being specified. After selecting the parameters for the flavor, click Create Flavor. Okay, we have a flavor. The flavor has successfully been created. This one. Task 3. Creating an image in an OpenStack instance. An image needs to be created before an instance can be created. In an OpenStack environment, the instance is created using the image that is uploaded. In this task, you will create an Ubuntu image which will be used for the instance creation. Okay, step 1, PLAB management desktop, right click the butty icon but minimize this one and minimize this one. Okay, click and open, and then we select deploy and then open. Root password, and then connect to the PLB controller node by establishing an SS connection by typing the following command. Controller, this one we already connected, and we type this one. I copy it and paste it here and then enter. Okay, it shows the SSH connection has been established to the PLAB control node. To determine the name of the container, type the following command. Copy, enter, Okay, the name of your utility container can be seen. Type the following command on the terminal to access the utility container. Okay, enter. It shows the command has been typed to access the utility container. Step 8. Type the following command in the terminal. Source open RC. Then enter. Step 9. To download the image, type the following command. It's very long. Certificate. Cloud images Ubuntu com. Initial current signal server. AMD disk. 1 image. Check certificate. And then we enter this. Okay, the Ubuntu signal image was successfully downloaded. In the utility container, type the following command to create an image with the disk format as QCOW2 and container format as bare. File name signal server clouding AMD64 this one dot image and image name test image this one. We copy it. It's very long. Then we enter. Here. The newly created image needs to be verified. Type the following command in order to list images. Copy. Enter. The image name test image with the status of active can be seen. Okay, this one status active. Task for creating internal network in an OpenStack instance. In this task, you will create an internal network in OpenStack. An internal network is used to connect specific instances to ensure communication between the instances. It can be compared to a switch in a physical network infrastructure. Instances in OpenStack are virtual computing nodes that are created. Step 1. After successfully creating the image in Task 3, open the OpenStack dashboard in Firefox from Task 1. Okay, but we minimize it. Okay, note, if the OpenStack dashboard is logged out, automatically repeat step 1, 11 task 2 to log back into the dashboard. Okay, can you imagine to show the dashboard of OpenStack which display the project? Click the project. Okay, click the project. Wait, this one, project. It shows sidebar menu of OpenStack dashboard while clicking network. Network in OpenStack dashboard. Click on Networks in the Network tab. Okay, in the Network window, select the option Create Network. and on the top right side, which will open a pop-up window. Create a network. And then, step 6, in the pop-up window, specify the fields of the network. Write the network name as intnet. Paste. And then click next. Okay, next. Type the following subnet name. Copy subnet and paste it. Then network address, this one, the 172.17.1.0/24. Then click next. Okay, it will open the subnet details. Click create to create the internal network. Okay, create. Oh, the internet network name int-net1, this one, successfully created. PIB manager displaying that internal network was successfully created. Task 5. Creating a security group in an OpenStack instance. In this task, you will create a security group in an instance. A security group is used to open specific ports in the network to facilitate communication, for instance, opening the correct port for an SSH connection. Click Project in the left tab of the OpenStack dashboard if necessary. Okay, wait for a minute. Clear Project. Okay, click Network in the tab of the left in OpenStack dashboard. Security group. Click the security group. Okay, security was selected. In the security group windows, select the option Create Security Group on the top right side, which will open a pop-up window. In the pop-up window, okay, create a new security group. This one. We create a new security group. And then, step 5, we put this name here. And then, create a security group. It shows the name of the security group has been typed followed by the click on the Create Security Group button. The security group name test SG is successfully created. After successfully creating the security group, click on Manage Rules of the newly created security group named Test SG. Wait a minute. Okay, create security group. Your group name Test SG successfully created. After successfully creating security, click on Manage Rules of the newly created security named Test SG. This one, Manage Security Group. Manage Rules. Okay. The Manage Rules window of the security group named Test Edge will open, which is currently displaying two rules On the top right corner, click Add on Rules. Add Rule. Step 9. The Add Rule pop-up window will open, in which the rule can be selected from the drop-down in the rule field. In this case, the SSH rule is required for the newly created security group named TestSG. Using the drop-down, set the rule field as SSH. We find the SSH. Okay, this one SSH. And then click on Add to add rule to the security group. Okay, SSH rule is successfully added in the security group named SSG. Okay, we're on the same page. It shows that SSH rule has been successfully added in the newly created security group. Task 6. Creating key pairs for the OpenStack instance for secure SSH connection. In this task, we will create key pairs for an OpenStack instance. Key pairs are utilized to securely connect to virtual machines using an SSH connection instead of using usernames and passwords. Public and private keys are used for authentication. Select the project. Okay, again back to project. Project. Compute and click key pairs. Compute and key pairs. Okay. In the key pair window, select option create key pair. Okay, pop-up window. Then we put it test KP. Here, test KP and click create. Okay, then next, the key that was generated will be stored in firm file format. In the pop-up, click OK to open generated in Notepad. Click OK. Okay. The private key that can be used for secure SSH connection is displayed. Close the Notepad application. Task 7. Creating an instance in an OpenStack environment. In an OpenStack environment, virtual machines are called instances. In this task, you will create an instance in the OpenStack environment. The previously created playboard, key pair, security group, internal network, and image previously created will be used to create the instance. Step 1. Okay, we click again the project, and we select instances. Okay, instances, and the instances window, select option launch instance on the top right side, which will open pop-up window. This one. In the pop-up window, the details tab is open. Type the instance name. Paste. Click next. Next. In the source tab, choose yes for delete volume and instance delete. But in the source tab, choose yes. Yes for delete volume. Choose yes for the delete all your instance. Okay, yes. Okay. Step 5. On the source tab, the test image can be seen in a available tab. Click on the up arrow. What? On this one, I see. On the source tab, test image can be seen in available tab. Click this one. The test image can be seen in the allocated section. Click next to move the playboard tab. Next. Okay, similarly, the test player tab, which needs to be allocated to the instance in the available section, click the up arrow to allocate the playboard. This one. Click. And in the playboard tab, test playboard can be seen in the allocated section. Click next to move to the network tab. Okay, network. Each though the playboard tab where available playboard has been allocated the instance following by click on next. In the network tab, the network name in int is already allocated to the instance, so click next to move to the network ports. No changes are needed in the network ports tab, so click next to move to the security group tab. In the security group tab, test SG can be seen in the available section which need to be allocated. On the insert, click on up arrow to allocate. In the security group tab, the test SG can be seen in the allocated section. Click next to move to the key pair tab. In the keeper tab, in the keeper name, test KP is already in allocated section, so click launch instance to launch the instance. Hmm. The new instance that was created is display. Okay. Keep the Firefox open. Browser open for the next task. Okay. Task 8. Soft rebooting an OpenStack instance. In this task, you will soft reboot the instance that was created in the previous task. A soft reboot is used if an instance needs to be restarted, but the processes that are currently running will shut down correctly. This process is similar to restarting a server using the correct method. Click on Admin and OpenStack dashboard. Mm. Okay, wait for it. Click Admin. Where is the admin here? Admin. Select the admin in the OpenStack dashboard. Click Compute and then Instances. Compute Instances. Click the checkbox next to the test playboard. Click the drop down arrow next to Edit Instance. Arrow down. Okay. The virus maintenance task on the instance display. Click on Soft Reboot Instance. Okay, this one, Soft Reboot Instance. In the Confirm Soft Reboot Instance pop-up that appears, click Soft Reboot Instance. The instance will be restarted. The test instance was successfully soft reboot. Alert. Wait for the instance to restart before progressing to task 9. Ouch. Okay, we select no task 1 2. Wait for the instant restart before progressing to task 9. Okay, I think we're good. Okay, task 9, hard rebooting and open stack instance. In this task, you will hard rebooting open stack instance. In this task, you will hard reboot the instance that was created previously. Hard rebooting any instance is the same as when the power of physical machine is switched off manually. This will be used if the instance has become too unresponsive and there is no other way to gain access to it. Click the text box next to test flavor. Oh, that's right. Click on the drop down arrow next to edit instant and click hard reboot. Okay. Oh, the problem is where is my no. Masyadong maliit yung ano ko. Ayun, okay. Okay, hard reboot. Then confirm reboot instant public hard reboot instance. Okay, success hard reboot instance. Alert, wait for instance to restart before progressing to task 10. The instance was successfully hard reboot. Yes. Task 10, shut off an OpenStack instance. In this task, the instance that was previously created will be shut down. An instance might need to be shut down for maintenance purposes, for example, adding more resources. Step 1, click the text box, test flavor. Okay, test flavor. And then click on the drop down arrow next to edit instance. On the right hand side, click shut off instance. Nope, yep. Shut off instance, this one. Shut edit instance, right hand click shut off instance. And then in the confirm shut off instance pop up, click shut off instance. Okay, successful. Shut off instance, test instance. Step 3, click text box next to test flavor instance. Click on the drop down arrow next to edit on the right hand side. Click hard reboot instance. Again, wait. Okay. the hard reboot instance again. We choose the hard reboot instance. Okay. There are different options available in red now after the instance has been shut down. In the confirm hard reboot instance pop-up, click hard reboot instance. Okay, hard rebooted instance test instance. Okay, task 11. Okay, alert. By selecting hard reboot instance, it will restart the instance. Wait for the instance to start before progressing to task 11. Ouch. Task 11. Create a snapshot of an OpenStack instance. In this task, you will create a snapshot of previously created instance. To create a snapshot in OpenStack is a way to create an image instance. So if something occurs in this infrastructure, the snapshot can be used to restore the instance of a specific point in time. Project. Okay. Compute instances. Select instances. Display. Select checkbox for test instance and click snapshot. Okay. Copy. Recreate snapshot. Okay. Snapshot test. Snapshot has been successfully created. Take a screenshot. Okay, the lab assessment. Next. Question. Which of the following directories store the configuration files for the OpenStack deployment? etc OpenStack deploy. Which of the following command is used to backup configuration? True or false is necessary to review the content of the backup? True. Oh, sorry, my mistake. Which of the following happens to instance and office environment when it's soft rebooted? The services of the office are switched off correctly before the incident is started. So when a snapshot environment is created, creates an exact copy. Okay, submit report. Yes. Click here. Save as PDF. Okay, save. Okay, we're done here. Feedback. And we're done. Okay, thank you for watching my video about maintaining cloud solution part 1. See you again at the part 2 maintaining cloud solution for part 2 for my next video. Thank you. Bye-bye.